As we begin our online lectures, I wanted to start by outlining what this chapter is. This chapter is about the Gibbs free energy equation. Delta G0 equals delta H0 minus T delta S0. You already know what delta H0 is. That is enthalpy from chapter 5. This chapter is going to teach you about entropy. This chapter is going to teach you about free energy. Please keep it in perspective. So, as we start, these little zeros up there, you've seen it before with enthalpy. That refers to the standard state. And the standard state, by definition, is 25 degrees centigrade and 1 atmosphere. As you're solving problems, you will find values for materials in the appendix, okay? So I want to say, let's break this chapter up into two pieces. We kind of did this before you left on break. We said, let's consider 19.1 and 19.4 together. There are two key equations. Delta S is Q reversible over T, kind of drops in out of nowhere. And delta S of the universe is equal to delta S of the system plus delta S of the surroundings. How I'm trying to help you see this is with two examples. One of them is a melting ice cube. The other is the synthesis of ammonia. So if I take hydrogen and nitrogen, I will produce ammonia. And I use both of these as examples to help you see how this works. So that's section 19.1 to 19.4. And I want to keep this brief, so I'm not going down any path of detail. When we get to section 19.5 to 19.7, the key equation there is this. Delta G is delta G0 plus RT ln of Q. Normally, delta G0 can come from Hess's law, or we can do the delta G0 is delta H0 minus T delta S0. Both of these will give us the same, relatively speaking, delta G. So what is this piece that's sitting out here? That is a correction factor. RT ln Q corrects for real conditions. So when we were back in chapter 15, we used Q when we had any conditions. We didn't know whether it was equilibrium. We didn't know whether it was at some other condition where we'd have to use Le Chatelier's law to talk about which way do we shift before we reach equilibrium again. So again, a lot of what you've learned before is used here. A key piece that's going to take us to the end of this chapter is we will say that when we are at equilibrium, our delta G will be equal to 0 and our Q is going to equal K. That is going to allow us to relate delta G to delta G0 to minus RT ln K. Very, very, very powerful relationship, and it builds on everything you've been sitting through since we started this class. I used as the example sodium chloride versus silver chloride. Many of you know silver chloride has a KSP. We all think of sodium chloride being soluble. So what I did is analyzed. Oh yes, I did steal the integrative exercise, but it allows you to see this relationship, because what you're going to be doing is you can find a delta G0 from a K, or you can say K is e to the minus delta G0 over RT. There are lots and lots of details, but the details are not the point of this little video. The point is, take a look at it before you jump into the course. Once you've worked your way through the information, come back and take another look at it and see if it starts to make sense for you. I'm available in a different way, no office hours, but available by email. Please do not hesitate to get in touch with me. I want you to successfully finish this course, and I'll do everything I possibly can to help you through.